I've had a couple of people ask questions. I want to get this done quickly so you can have a chance to review this before you leave for the exam today. Um, Solving these electric circuits. So let's take just a quick look at there's whenever you've got one of these circuits to solve, you've got three choices. You can either use Ohm's law, you can use Kirchhoff's voltage rule, or you can use Kirchhoff's current rule. So Ohm's law is that relationship between voltage, current, and resistance. The voltage rule says that all the sum of the voltages in a loop, you're going to look at a loop, is zero. The current rule is the sum of currents in a node. So the sum of the current going into or out of a node is zero, or the sum of the currents in a node is zero. So going in is out is we call it positive, out is negative. We look at the loop. So if I look at a voltage gain, like a source over here on the left, that would be a positive voltage in the loop, and voltage drops would be negative voltages. Now, if you look at this root, because we're going to look at this loop here on the right. If I say pick this point X at the bottom, and if I follow my loop sort of up and around this way, coming around and back to here, the voltage drop. There's a voltage drop against across R2 in the circuit as the current flows. But the thing is, we're going back up that path, and so that would actually be a voltage rise, and we'll get to that in a second. At any rate, so let me just get rid of those lines here for now. And we'll discuss how to do this. So again, you've got three choices when you want to start looking at these solutions. If you're looking at the voltage rule, you have to look at loops. The current rule, you look at nodes, and then Ohm's law is just you look at a given device. Do you know two pieces of information, and can you find a third? And that's essentially the way it goes. So what I would typically do is I would scan the circuit and look for what I've got. So quickly, I'll just put little check marks beside each one. So I know the voltage source, I know I1, I know V1, I know R2, and I know R4, and I know R5. So sort of quickly scanning this, I look at a couple things. Right off, I know two pieces of information about this device here. So I know the voltage, I know the current, I can figure out that resistance. An interesting thing is I also know two pieces of information about this, because I know this resistance, and since I1 is the same as I5, or going through R5, I also know the current there. I know the current and resistance. I can find the voltage. So I can pick either one of those and start. Let me start with the first device. So if I use Ohm's law, if I use Ohm and on R1, I know that V1 equals I1 R1. So I know the voltage and the current, so I'm going to solve for R1. So it's V1 over I1, and I believe this was V1's 10 volts, I1 is 1 amp. So I've got 10 volts over 1 amp. So R1 R1 is 10 ohms. So I can go put that into my table. So now and I can do the same thing for R5. So I know that R5 is 5 ohms. So V5, which I don't know, but I can fill that in, is I5 R5, but I5 is just R1 is I1, so this is going to be 1 amp times 5 ohms. I end up with 5 volts. So there we got two additional pieces of information that I didn't have before. So now I'm going to use the the voltage rule, Kirchhoff's voltage rule, and I'm going to call this loop A, and I'm going to call this loop B. So if I look at loop A, now I know V1, I know V5, and I know R1. So if I know the source voltage, I know the voltage drop across R1, I know the voltage drop across R5. The one that's missing in here is V2. So I can use the voltage rule to say that the sum of all the voltages in loop B is 0. So I know that Vs plus V1 plus V2 plus V5 equals 0. Sorry, that's an S, not a 5. So I know that the source voltage was, what, 25 volts? Yeah. I've got 25 volts plus negative 10 volts because it's a drop. Yep. Plus V2 plus negative 5 volts equals 0. So I've got 25 minus 10, so then V2 has to equal 10 volts. So there I've got another number that I can put in here. I've got 10 volts. And then I've got Ohm's law, because now I know V2 and R2, I can find I2. So if I've got 10 volts divided by 20 ohms, this one's going to be 0.5 amps. So I've got 10 divided by 20. So that's 0.5. So there I've got this information here. Now I'm going to call this node X. If I look at node X, I'm going to use the Kirchhoff's current rule, because I know I1. I can say that I1, oh wait, no, I guess I have to, yes, I found I2. If I want to find, I know that I1 plus I2 plus I3 equals 0. That's the current rule. And so if I look at current going in as a positive current, I know that I've got 1 amp. Current coming out, I'll consider that a negative. So 0.5 amps negative equals plus I3 equals 0. So I have 0.5 amps, 1 minus 0.5 amps plus I3 equals 0. So I3 equals negative 0.5 amps. And the only thing I worry about this negative is I just know the direction that it's going, and it should go in this direction. So this is I3, and so coming down through this positive terminal, this one here is going to be 0.5 amps as well. And if I3 is 0.5 amps, I4 is also 0.5 amps, because it's in a series circuit that current is going to be the same. So I've gotten I3 and I4. And I could also use, if I wanted to look at this node Y, I could say that I've got 1 amp coming out of there. I have to have 0.5 and 0.5 going in, so I could solve that as well that way. So now if I know I3, so I guess my next step here is, because I know I4 and I know the R4, so if I've got I4 and R4, I can figure out V4. So I'm going to use Ohm's law over here. So let me use Ohm. So Ohm's on R4. So if I have V4 equals I4R4, so R4, no, sorry, it's R4 that I know, right? Yes, I know 10 ohms. So I don't have to solve for R4. I'm just going to plug and play. I've got 0.5 amps times R4 is 10 ohms. So I end up with 5 volts across R4. So this one becomes 5 volts. I want to point out, like, just because you got two resistors here, they split the voltage, that isn't always the case. It just happens to work out nicely in this solution, but that's not always the case. So if I know now I know V4, and if I look at loop B, I've got 10 volts across R2. So V2 is 10 volts. So this is 10 volts. This one's 5 volts. So if I go up 10 volts, because this is a drop, so I go backwards across the drop, I've got 10 volts, and I drop 5 volts. This one here has to also be 5 volts. So V3 is 5 volts. So they do share it nicely. And then if they share the voltage evenly, then that also means that the resistors have to be the same. But let's just check that to make sure. So now we've got V3 is 5 volts. We know that the current is 0.5 amps. So if I have 5 volts divided by 0.5 amps, I'm going to have 10 ohms. And sure enough, the R3 and R4 are the same resistance. So that's how you solve these circuits. Notice that none of the steps was complicated. You just have to take, it's like any sort of big problem. You take it down, you break it down into chunk-sized pieces, and you should always be able to solve it if it's a solvable problem. So again, the chunk-sized pieces that you want to look at, I want to be able to solve things. I know that I've got three tools. I've got Ohm's law, I've got Kirchhoff's voltage rule, and I've got Kirchhoff's current rule. And you have to sort of scan the circuit, find the parts of the circuit where you have enough information to solve it, and then they can go away. So take a look at that. There, yeah, you will need to solve circuits on the exam. So get comfortable with this, and good luck.